This is video number 8 on our Introduction to Robot Design and VEX Parts, and we were left off talking about the 393 motors. They also have step files available which can be imported into various solid modeling packages. So I imported the VEX 393 motor into this. It's actually SolidWorks, but it doesn't have to be SolidWorks. You can import it into other things as well. And this is an assembly. You can see all the parts here. If I click on this right here, you can see that lights up in blue, so that's that part. And I can change the transparencies so that I can actually look inside these. So these different parts here, I'm just changing the transparency so we can see what's inside. So this is interesting. Here's the motor right here, and so here's the first reduction. So you can see that, maybe this gear this is called a pinion. This needs to turn maybe 4 times to get this shaft to turn once. This shaft, meanwhile, is connected to this other pinion here, and with this pinion has to maybe turn 4 times for that one to turn, and so on. So we've got 4 times 4 is 16. This one has to turn 16 times to get this one to turn once. And it just goes, you can see there's actually 4 stages. So now maybe this is another 4 to 1. So that's what, 64 to 1. And then so on. Maybe this is 3 to 1. So that would be what 192, something like that. So this motor has to turn 192 turns to get the output to turn once. So that way you have a motor that can spin very fast but doesn't have a lot of torque. So now you have this output, and I think the numbers were something like the standard was, the no-load speed would be 100 RPM and the stall torque was like 1.67 Newton meters, something like that. So anyways, you can see that you get the whole model here, and you can just input this into your assembly for the robot that you're actually building. So that way you can create an entire solid model of your robot before you actually put anything together. And these things also have masses, and so you can also check what the outer dimensions are. You can check how much the robot's going to weigh, make sure that it's coming under the specifications for weight and so on. So again, there's a summary of the outputs. Yeah, there's the 100 RPM free speed, no load speed, and stall torque 1.67 Newton meters for that particular motor with those gears. You can change the gears, of course. They also give you the weights here, material type, and so on. So if we go back here, let's look at, there's motors. What about wheels? So we can look at the types of wheels they have available here. These are the Omni wheels. So these wheels are nice in that, so in other words, if you're driving straight ahead, you can get some traction. They don't have a tremendous amount of traction, but a decent amount of traction. But then if you want to turn, remember we talked about how much power, how much torque is required if you have skid steering, because you have to drag your wheels laterally, right? Well, these Omni wheels have rollers so that there's very little friction when you try to move these wheels sideways. And so you can get traction when you're trying to move forward or backwards, but when you're trying to turn, there's not a lot of resistance. So that makes it a lot easier to turn. Of course, if you're in a competition or a tournament where it's okay to push on other robots from the side or something like that, then maybe you don't want that no friction in that direction. It depends on what you're trying to do. Another type of wheel that's really interesting are these mechanism wheels. So we're going to look a little bit more closely at those. It's a pretty strange looking wheel. And here's a solid model that again downloaded from the VEX website, and you can see that those have a lot of rollers and a lot of different parts, but you can download that model and put it into your robot. So when might you want to use mechanism wheels? So we're back here on the VEX website, and I'll just pick mechanism wheels, and I'm going to have to stop here and pick up with the next video.